Welcome. So these are two questions which are about momentum. And the first question says, what is the momentum of a 3 kilogram block traveling at minus 4 meters per second? It's traveling at 4 meters per second in a negative direction. So let's visualize to begin with. So here's our 3 kilogram block, and the size of our velocity is 4 meters per second, but it's pointing in a negative direction. So we have a velocity like that, and I like to put minus 4 meters per second so that I have it. And then I say, well, P is equal to mv. So P standing for momentum, is equal to 3 times minus 4. So P is equal to minus 12. And the units would be kilograms because of the mass, and meters per second because of the velocity. So on a number line, if we're working in one dimension, that's just a straightforward example of how we'd work out our momentum given mass and velocity. But we don't always work in one dimension. Sometimes we work in 3 dimensions, and this brings into IJK notation. And also remember that momentum is a vector. So what we'd say here is, what is the momentum of a 5 kilogram block that has a velocity of 3i plus 2j minus 4k meters per second? So here we have a 5 kilogram block, and this guy has got a certain velocity, and this is going to be 3i plus 2j minus 4k meters per second. And the equation is just the vector equivalent of the first equation. So it's a momentum vector is equal to m times momentum of velocity, and then times the vector velocity. So we simply say, well, the vector momentum is equal to, in this case it's going to be 5 multiplied by 3i plus 2j minus 4k. So that would simply equal 15i, I hope I can fit this all in, plus 10j minus 20k, and don't forget your units, kilogram meters per second. So there's the IJK notation for the vector momentum. And if we wanted the magnitude, we could get the magnitude by using, the 3-dimensional Pythagoras. And if I wanted the direction, I could represent the direction of this by simply taking the unit vector, which is this vector divided by its own magnitude. So don't forget your basic vector skills. So here we have a number line representation of a momentum, and we have a IJK notation representation of momentum in 3-dimensional space. So there we have it.